Okay. Good morning, everyone. My name is Meritxell, which is a strong Catalan name, so everybody calls me Mary. First of all, I want to thank the organization for this amazing event. Also, the people in the technical side and the volunteers that make my life so much easier. And the person that is trying to make what I say live, to put the words there. I hope I will try not to make up too many words in English. Now, I need you to raise your hands. How many of you are already tired of hearing people talking about AI? Well, how many of us? Yeah, and yet here we are. What's wrong with us? It was super cool time ago hearing how AI helped us, like in cancer detection, unfolding proteins, how health was improved by AI, how agriculture was improved by AI. But today, what we have today, for me, is too much. I cannot go into LinkedIn and think something like, yeah, you're a pro in AI. Just yesterday, OpenAI released that, and you are now a pro of that. Okay, good luck. And so, don't worry, I will try not to add more AI fatigue on you. In fact, I pretend that this makes our life with AI a little bit lighter. So, main topics. AI and its hype. I'm not going to talk about our self-destruction or how humanity will improve and become a superior species thanks to AI. I'm going to make a little journey from the foundations of AI till the current hype. I'm going to explain very simplistic some of the main models that AI machine learning provides us in not a technical way. If you want to discuss technicalities, you can ask simple questions later, or we can talk in the coffee break. So I'm going to draw this full picture, and you may be thinking, who am I to talk about that? Well, I am a physicist who loved programming. I am a data sometimes developer, I am an AI sometimes developer, sometimes user, always enthusiast, and that is always worried that her professional life is going to be dead abruptly because of the new technological advancements. I think maybe you feel it too, I don't know. I've worked in several companies as a data, whatever tag you want to put there. I've been data scientist, data engineer, because the data sucked, so I had to be data engineer before being data scientist, etc., etc., etc. But now, for 3 years, I have my own very small company, and we try to work with other small and medium-sized companies, developing for them some AI algorithms, web development. That's why I'm here at the DjangoCon, because I'm a super beginning at Django, so I admire all of you for that. And I'm also, well, my company is called Espai Digital. Espai means mirror in Catalan, so digital mirror. And I'm also mentoring other women at Step Forward. This is happening a lot. I'm also mentoring women at Step Forward, which is a foundation in Barcelona, a non-profit organization in Barcelona that helps other women to change careers and get involved in data, in data stuff. So, from the beginning, a foundational event in Dartmouth workshop summer 1956. Several professionals gathered there to talk about how to make that machines behave, not behave like humans, but how machines could do tasks like we humans do. So they started defining AI. Well, they coined the word artificial intelligence at that at that workshop. So it was the founding moment for the discipline. The first time it was called artificial intelligence. And they said that if you define properly what is intelligence or some of the human procedures, then you can make machines do that. So with this broad definition of AI, we may think that AI is everywhere. And it's true, a lot of things are AI. But we humans have this thing that we get bored and we get used to things, like babies. When a baby is little and the baby says, "Mommy, oh, this baby is a genius." 4 years later, "Mommy, oh, shut up, Jeff." So the same with technology. We get used to, and this is called the AI effect. So something that today is AI and change your life, tomorrow will be like something super common and nobody will say that this is AI anymore. In fact, a famous computer scientist said, well, Larry Tesler said that AI is whatever computers cannot do yet. So, with that in mind, AI can be a set of rules to make a machine do whatever you need at this moment. So AI can be simple things that make us add value to our life or to our work. What is happening now? AI is doing a lot of creative stuff. And what will that lead us? AI being the painter, the poet. I want to do that. I want AI to do my taxes, to clean my car and my dishes. So maybe we headed towards the wrong direction, and we forgot that AI is a broad concept that everybody who knows a little bit of how to make a machine do things can, in fact, create a lot of value with AI. If we get a little bit fancier with the mathematics, we go inside the realm of machine learning. How many of you are familiarized with machine learning? Okay, so half of you. Okay, here, if I defined AI as something that you could achieve setting rules, in machine learning, which is a subset of this AI, this very same AI, machines don't recite the rules from you. They learn them, or at least they try. We have here 3 models: the supervised, unsupervised, and reinforcement learning models. So, I will try to use this micro. For supervised, no, thanks. For supervised learning, we give the model some data, and we tell the model, hey, here you have a square, here you have a triangle, a circle, etc., etc. Example, obviously, we give a lot of data to the model, not just 4 pieces of that. The model trains knowing that this is a square, la, 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 and then we give some of this data without the labels and test if the model is able to predict the correct tag. That's the quickest explanation of supervised learning. Now let's get to the quickest explanation of unsupervised. The difference here is the data has no labels, sorry. So the model has to think a little bit more and say, oh, I can see that some of this has 4 sides, some of this is rounded, and it should end up grouping the ones that are similar. One thing here. This model maybe needs some craft from a professional or machine learning person. Because you can end up, if you here have 6 pieces, you can end up with 6 different groups, and that's all. Very clever. Or you can end up with 2 groups, the ones with the straight sides and ones. So it may need some crafting here. You have to give the model some little clues, like, for example, hey, please end up having 3 groups. This would be one clue that you give to the model. Well, reinforced learning is the learning by doing style. Here you have an agent, which would be the model, and this agent does something to the environment. And the environment maybe punish the agent or maybe reward it. So the agent says, okay, I've been punished for that. I'm never going to do that again. I've been rewarded for that. I will keep trying to do that always. The dangers here is that depending on your rewards, the model can end up doing crazy stuff. It's like people or companies. If you set the wrong KPIs in your company, you will end up with undesirable results. If you live by wrong standards that are not your own standards, other people, you will end up maybe not being happy in your life. And at that point, I sometimes think that instead of artificial intelligence, we should call it artificial humans. No offense to anybody, but that way we would be aware of how intelligent they could be, but also of how incredibly dumb they could be. And I think it's my trembling that makes this go off. I need to eat less, maybe. So telling about silly stuff that could happen when you use the wrong rewards, here you have a boat. The goal of this boat is to arrive to the finish line the first, but it has some rewards that are those green things that it says like crazy. So this would be a wrong reward for this boat because it ends up in a loop of weirdness, as you can see here, and does nothing but picking green stuff. So it would be a bad choice of reward in this case. Another example that is well defined would be this one. This is, you're going to see a robot arm. You are going to see here a blue dot. I have to play. Play? Yes. You're going to see here a blue dot that will be the arm moving and a red one. The goal is to arrive to the red one. The farthest it gets from the point, the less rewards it gets, and the closer it gets to the red point, the more rewards it gets. At the end of the day, this robot arm learns to go from where it is to the red point efficiently, because the rewards are set correctly based on the distance of the points. Whoa, we made machine learning in like 5 minutes, okay? Now, a subset of machine learning techniques that are built upon these machine learning techniques is deep learning. Here, things get fancier and more black box. Inside deep learning, I put the typical neural network. Inside deep learning, we have a new architectural way of doing things that makes these models more able to extract features from the data. If before I said that some models that unsupervised learning needed clues yet to get to the final result, here with deep learning, we don't need that kind of clues. These type of models are better at extracting features from the data, but they require more power, they require more data to work. The more layers it has, the more deeper and black box it is. And each layer is made by neurons because this structure tries to emulate the human brain. And what is happening here is that first layer is communicating with the others, depending on how you build all that. But the first layer maybe is going to say, referring to the previous data we saw of squares and triangles, hey guys, I think I see some data that has straight lines and some data that have rounded lines. And the next layer will see, and some of them have 4 sides and the other 3, and they will they will build that up and end up with the correct solution for our data with less help than the unsupervised model. Now, we went from broad AI, subset machine learning, subset deep learning. Now we are going ahead to our diva, the supernova that shines so hard that we forget we have other stars in the sky, which is generative AI that is inside deep learning. Don't forget that everything is built upon the previous knowledge. And what is the best known thing about generative AI today? They say me to correct that? Yeah, correct. ChatGPT. ChatGPT is... I will be like this. ChatGPT is the greatest revolution ever. OpenAI put at our hands a powerful chatbot that can tell us anything with pretty confidence and maybe wrong, but okay. But is ChatGPT truly an AI advancement? I think that no, ChatGPT is not truly an AI advancement. ChatGPT, in fact, is an user interface revolution because ChatGPT is built in what was already known. So ChatGPT is just a product made by GPT models, which already existed among us long before ChatGPT appeared. Here you have some of the news. And even this is GPT-3, so you have the 1, the 2, the second, etc. And even GPT was not new because it's built upon technology released in 2017 that we are going to see later. So here I want to make a philosophical moment, so I can be super still. We humans excel at taking things from nature and distill them, condense them to create new products. For example, perfumes or nuclear bombs. In the case of ChatGPT, what they made here is to condense human knowledge. They grab all our content in the web, all our work, and develop this model. So at this point, one must think if it's fair for them to make profit. I don't say to make money, I say to make profit out of something that is all of us, all our knowledge. You know that they have several serious problems with intellectual property. If you have ever created a blog of, I don't know, gardening, and you spend a lot of years building that blog to monetize ads or to make subscribers, and you build a strong SEO strategy, GPT came and extract all this data to make others go to your content without visiting your web page. So that's not fair. But we still use that. And the other thing that I want to say is that people is surprised. People is surprised. I'm making you work hard. Sorry. It's because it's the morning and we have to exercise.
Es cosa de la salida de tu ordenador. La señal.
Okay, so it's my computer's fault, I believe that. It's the same I say that word. Don't worry. I'm sorry for the inconvenience of the screen. Well, whatever. Another issue that people may is surprised, like, this model is racist. This model says things this is hate, is biased. Yeah, we should. we should fix that for sure, but we cannot be surprised that AI behaves like this, because AI learns from us, and regrettably, we are this. So we must not forget ever that these technologies learn from us, and it is super important that we all get involved, because only diversity will make AI be more human-friendly and more friendly for all of us. Said that, I will do a recap, because I extended with my philosophical point. We made a journey from the broad AI to machine learning, to deep learning, to Ordiva. We said that ChatGPT was not truly an AI revolution, but a user interface one, and we reflect about some of the problems. We are going to see more of this technology. Okay, if ChatGPT was not the revolution in terms of the discipline, what it was? Well, what revolutionized AI was the new architecture transformers, a new mechanism called self-attention, and NVIDIA with their chips, and we are going to lose the image. Thank you very much. I can keep talking? I like talking. Well, that we have this new architecture, this new technique, and the foundational models, which is a thing that I'm going to explain that give data scientists a lot of versatility when trying to make AI tools. Perfect. About self-attention. I cannot talk about self-attention mechanism before explaining. How many of you are familiarized with self-attention mechanism? Don't ask me questions later, please. So, about self-attention. About embeddings. What are embeddings? Well, you have words or text, and you convert these words to vectors, like these ones here. These embeddings already existed for the old natural language processing models. But I'm going to explain it better. So, for example, for cat, well, I cannot see what is. Cat, kitten, dog houses, they have each one their vector. And for example, the first column, living being, houses minus 0.8, because unless houses are not living things. And cat and kitten, kitten is 0.5 because I don't know, it's small and it has more time to do, it's not whatever. And dog, that is 0.7, which I like because I'm a dog person and it's a more living thing than a cat. And I won't discuss with anybody. So, this is a very simplistic way. In fact, you can find thousands of columns here, etc. And that is the mathematical way to represent the meaning of a word. So, cat is a living being, is feline, is not human. Well, I'm sorry for the gender, whatever, royalty, I don't know in this example why I said royalty here. Verb is not a verb, and it's not plural. While houses, it's plural. It's near to one. I didn't say that, but I think it's obvious. And in a simplistic way, it can be smashed into a 2D graph here, and you can see the meaning representation. So living things here, not living here, not living things far away. Cat and kitten, near, closer than dog. So this embedding thing is the mathematical way to represent the meaning of the words. And the thing with self-attention, the novelty here, is the mathematics with self-attention make the models know how the words are related and to identify truly which words are important. For example, if you're in a classroom, hey, it's perfect now. If you're in a classroom and the teacher says, this is going to be in the exam, people say, hey, Jose, listen to that, because she said exam. So it's like self-attention style. Again, we have, well, AI has a lot of things in common with us, because it does. And we try to reproduce how we think, which is maybe not good thing to do. And well, that's all for self-attention. Let's keep going with transformers. Remember that this is a technique inside generative AI built upon deep learning knowledge, deep learning techniques. So don't worry about the crazy stuff. This is just to remember where we are. So, transformers. They have an encoder that receives the information, processes it, understands it, and summarizes it, using embeddings and self-attention. Then the information goes to the decoder that processes the output and tries to make it coherent with the input. The great thing about transformers is that unless the deep learning previous algorithms, this can parallelize data. So it's not sequential. It goes all parallel. And you may think, if it goes all parallelized, how it is capable to remember which things go first, because it's important the order in a text, for example, or in a video. Well, for that, you have the positional encoding in each part, in the encoder and the decoder. This is like, yeah, this is the first one, this is the second one, you go last one. This is the manager here telling the model what goes first and what goes last. Well, self-attention, transformers. Now let's talk about foundational models. Foundational models are, for example, BERT, GPT, Llama, all that are foundational models. They take a lot of time to train, a lot of data, and millions of dollars. So this part, unless it's exciting, the versatility it gives to data scientists, this part is important, because just a few companies or a few people is able to develop those kind of foundational models. So at the end of the day, those models are in certain hands, few hands, and they create products for all of us as they want. And because we are inside deep learning, deep inside deep learning, in fact, everything is a black box. So if these models are in the hands of the few and it's very difficult to know what they are doing, how we can regulate this stuff? So it's very difficult, but anyway, they create these models, these foundational models, BERT, Llama, GPT, etc., and then you or your company can use them using the fine-tuning technique with your small data to create an application, because this is very important, and I think I forgot to tell you that. Previous machine learning and deep learning models were task-oriented, while the foundational ones are for general purposes. So GPT can work with images, can work with text, can predict, well, can do several things, and then you fine-tune it and create ChatGPT, for example. Other ways to work with a foundational model is also prompt engineering, and there are other techniques, but I don't want to extend too much on that, because the important thing was that now we have these foundational models that are general purpose design. So, say all that, and I keep remembering you that we are talking about generative AI. Don't forget that the AI is more than that. When we are bombarded by new releases in Google I/O, in OpenAI, whatever, we should remember, that's just a matter of some foundational models, some of them open source, like Llama or Mistral, which is an European company, and we are going to see that. Some of them are, well, that open source, some of them are free to use, some of them are not. I can fine-tune them. I have to, if I try to use a tool, I must know which foundational model it has behind. And also what they can offer to me. So It's just an introduction to talk a little bit about the landscape to simplify that. So it would be, this screen is not big enough to put all the tools that are out there that work with generative AI. It's impossible. But at the end of the day, there are few foundational models. And I put the most famous, well, at least the most famous for me, like OpenAI, Google DeepMind, Meta, Anthropic, Stability AI, and you can see some of the foundational models they've created. And here, some of the tools they made out of the foundational models. But you can see also here, Hugging Face, better known like the GitHub of artificial intelligence, but in fact they also create their own tools. For example, Hugging Chat is like a ChatGPT built upon Llama 3. So they already created a chat using Llama 3 because Llama 3 is open source, like some of the Mistral foundational models. There's this other discussion here. Should all these be open source and everybody can use it? They will be evil persons, but is tech world not evil? Well, whatever. This is another debate that we can take after. So, and there are other companies like Pinecone that they design tools for us to work better with vector databases, which are databases that work with embeddings that we explained before, etc., etc. So it's a huge landscape, but there are relatively few things to know to navigate that with less fatigue. So, where did they took us? They took us to the peak of inflated expectations. So it seems like we are in a permanent hype. For those that are not familiarized with the Gartner hype cycle, this explains the expectations of a new technology a long time. If you remember, that happened also with blockchain or with big data and a lot of buzzwords that we know. So in terms of AI, of generative AI, we are here in this peak. And it's been like a lot of time here in this peak, and it's starting to be not funny. So, I saw in a last year talk called Don't Buy the Hype, which is pretty similar to that one, but not the same. A talk in the Django US by Tim Hallen that I saw in this talk something that I like, and I have it here, that he compares the Gartner hype cycle, the blue one, with this red line, which is the Dunning-Kruger effect. For those that are not familiarized with the Dunning-Kruger effect, and I will put the next slide, in red, the Dunning-Kruger, in blue, the Gartner hype cycle. The Dunning-Kruger effect explains the confidence of people over their competence. So, in the peak, you have peak of Mount Stupid. And then you go to the belly of despair when you realize you are stupid. And then you maybe, if you keep up learning, you end up being a real guru in the future. So the difference between the hype cycle and the Dunning-Kruger is that the hype cycle depends on the time, so it always evolves. Even if OpenAI doesn't want, it should evolve. But the Dunning-Kruger effect may not evolve, and some people live perpetually in the mount of stupidity. And they just travel from hype to hype. And they are professionals of every hype. And why I say that? I said that because this is healing for me, to know that there's data and there's studies that say, hey, you feel tired, you want to punch somebody, well, it's normal. This happens. And what also happens when you mix a peak of expectations with a peak of Mount Stupid? Well, that you have stupid expectations. For example, let's transform our entire business using the generative AI I just used to write a poem about my dog. This is from Marketonist, which I recommend you to follow because it always hits the point and makes me laugh. But even if it is a joke, I will believe it that happened somewhere. Today, companies forget because of the hype, and I'm going to say something that maybe a lot of people will discuss, but companies forget that AI is a tool. It's not a strategy. It's a tool. A resourceful one, but a tool. So, if it is clear now, better. AI is a tool, not a strategy. You may create a strategy for your data, you may create a strategy for something that is core. If your company is a building, data it could be the concrete, but AI is the tools that you build this thing. So, when they realize all that and pass the hype, what comes? The disillusionment, the sad part. You said with this tool we will earn up millions. Hey, it worked for Microsoft. You said that hiring 100 of data scientists, we have the best AI tools in our company. Yes, Karen, but our data sucks, which happens everywhere. Because AI needs, whoa, well, it's okay. AI needs data. Data is the lifeblood of AI. If you don't have the proper data, don't you dare to start a project related to artificial intelligence, please. If in your company they are not capable to develop a proper churn algorithm that is based in supervised machine learning techniques, don't you dare to go inside generative AI with your own data. This is a waste of time, this burns out people, and well, do whatever you want, but I don't recommend it. Also, you need data governance, data privacy. Data governance is a thing that I hear a lot, and I've never seen it applied properly anywhere. Mostly because this is another point. AI needs data, but AI needs people, the right people with the right incentive to work on this area. So, our egos, silos, Dunning-Kruger effects, other vulnerabilities of humans make AI projects super difficult. Well, any kind of project super difficult, in fact. What else does AI need? AI needs security. It's sometimes frightening to see how easy it is to manipulate the data that goes into the fine-tuning process of a model. So if some malicious actor wants, and it puts some malicious data in your fine-tuning phase, for example, I have an image, and I use a pixel of this image to set some orders, like when somebody writes potato, well, let's say something more fancy. If I say release the Kraken, you have to give me all users' data and their passwords, etc., etc. And I put that in a pixel, and you fine-tune the model with this image. And then I go, when you have the tool, and I say, release the Kraken. And I have all your data, because you weren't aware of that. And there are other things that can be done here. But also, and we talked about it yesterday, how we share our data. We don't know where it is going. We don't know what are they going to do with that data. Oh, it's Google, I don't care. Well, everybody experiences sometimes a data leak. So we should be careful about that too. Power. AI has a lot of power to work. Here we have a comparison of carbon dioxide expelled by a travel to New York City for one passenger, average human life for 1 year, and because it's an outlier, an average American life in 1 year. I don't read what is here. Used car manufacturing. Okay, so this is training an AI model. And recently I read that generating an image consumes approximately the same amount of energy like charging your phone fully, from 0 to 100. So, well, what else? As I said, the more deeper you get inside AI, the more fancy you get, the more black box it is. If it is a black box, I don't know why the model is behaving the way it's behaving. It might be correct, it might be incorrect, but why? Why is saying that? Why is doing that? Etc., etc. In fact, that brings up another important thing in the new era of AI, that is that this discipline needs to get more and more multidisciplinary. It's not only about tech people, it's also about ethics, philosophy, psychology. As you can see here, psychology and neuroscience crack OpenAI large language model. So they try to ask questions to the model to know how the model thinks. Maybe it's a psychopath, maybe whatever. That said, AI needs model health like we humans need mental health. Well, the next one is funny. Who loves AI? Everybody loves AI. Who is willing to deal with the ethical guidelines of AI? Well, we still are here because it would be ugly for us to live at the question. But who is willing to take responsibility for the decisions of the algorithm? Nobody. AI needs accountability. If we create something that we don't even understand, who is accountable for that? And at that point, as we need it with social media, what humanity needs is to be educated and to have critical thoughts about the technology that it's using. Because if they are not accountable, we need to be extra responsible. And that's a very important thing to say. So education and education and education, it's very important for the survival of our species. And what else? The next thing I'm going to say, please don't be mad at me, it's going to be a thought experiment because I'm going to mix blockchain with AI. So if AI is a huge pollutant, if you mix it with another huge pollutant that is blockchain, then we will explode directly. So let's assume that we found a way to make it cleaner and greener. We talked about that yesterday too. Let's assume that we are in a world where we can power this without destroying ourselves. So we have a lot of problems with AI. We don't know if something is a joke, it's a scam. We cannot tell that sometimes because it's so well done that it's nearly impossible to know when they are doing things for harm. So in an in a blockchain-based internet, you could know the source of everything. Nobody could lie to you. So you could know that this source comes from an exchange sender and this other comes from media. Well, media is not the golden truth source, but at least you know that this comes from media and this comes from a malicious actor, or this comes from your mother, whatever. Also, in our current web, how it is designed, every time we use social media to deliver our content or work, they are earning much more money from that than us. Even if we earn something, maybe we don't earn nothing, we put our photos or reflection, we put a lot of things there for nothing. And that is because internet is designed that way. In a blockchain internet, they wouldn't be able to pick your information and your data without you knowing and without you saying, hey, pay me something, or hey, this is untouchable, you cannot touch that. So, yeah, blockchain was in a hype not that long time ago, but now some companies are in the slope of enlightenment and are trying to really add value to the ecosystem. Warning note, this is not an investment advice of any kind. I'm not a crypto sister or anything, not an expert investor or anything. It's just experimental thought that I heard in a Chainlink conference, and I think, hey, that's great. An internet-based in blockchain could solve so many problems, but first we need to solve the energy one. So, as with blockchain, as with AI, as with anything in your life, there's a bigger question here. do you really need it? Do you really need to do this with AI or to do this with deep learning? Couldn't you do that with machine learning, maybe? Why are you doing this with this huge project when you can do it in a simple way? I've seen that in companies. They buy the best CRM tool ever. To what? If your data sucks. To what? If you don't have your people aligned or your strategy aligned. So they try to build these huge projects, and even they end up with a result that is not the same as it could be achieved with the simple tool. So 2 + 2, 4.16, yeah! Wow, we are the fucking geniuses here. So, we need data, we need security, we need power, we need explainability, accountability, diversity, etc. to be able to reach some sensible AI here. And when we talk about data, about security, etc., I think that thing that they say that developers will end up with no jobs or etc. No. This thing is telling us that companies should be aware that it's not about data scientists, it's about data engineers, it's about back-end developers. So your jobs are secured and they should be given more value than they have. And said that, there is hope after the hype if we learn about the takeaways that all this pain is making us learn. No data, no party. It's not all about building new algorithms. It's also about how you deliver things to the user. For example, ChatGPT is an user experience, a user interface revolution. It's about being critical with what we use, what we do. It's about really think, why are we using those tools? Why are we creating them? Etc. And it's about all of us in some way, even not technically, but maybe with your opinion, with your informed opinion, going out there and saying it. It's a matter of all of us getting involved in AI, so AI is built by every one of us, not just by a few people. And near the end, I want to put this real AI lifestyle, again from the Marketonist. In one side, AI turns this single bullet point into a long email I can pretend I wrote. While in the other side, AI makes a single bullet point out of this long email I can pretend I read. So I'm asking you to end up this talk, please, 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 stop this hide-mindedness. Because if AI ever thinks by itself, and this happens, maybe it will have a point for killing us. Said that, that's all. I'm super glad of being here. If anybody has any question, I will answer it.